Hello and welcome to the next skill view review video covering other types of equations. You remember from Algebra 2 seeing all sorts of different equations in terms of working with them. And so our skill objectives for this video are going to be one, solving rational and radical equations where we're dealing with variables in the bottom of fractions or under square roots or cube roots or so forth. Solving equations that are quadratic in form. They're not quadratics, but you can express them similar to a quadratic function and therefore factor it that way. Solving other equations that are factorable. Maybe they involve cubes, maybe fourths, so forth. So you're working from there. And then also solving absolute value equations. The conceptual objectives for this video: transform an equation into a simpler linear or quadratic equation. Recognize when extraneous solutions are possible. These are values that come up when you solve it that do not work in the original problem. And then realize not all polynomial equations are things that are going to be factorable. The first thing we want to look at is the rational equations. In this case, the example I have is 1 over c plus 2 plus 1 over c equals 2 over c times c minus 2. So in this situation right here, the first thing we're going to want to do in terms of solving a rational equation is to go through, identify a common denominator, and multiply through by that common denominator. Now, ideally, we'd like to identify the least common denominator. That will make our life a little bit easier in this case. So for this one, the least common denominator is c times c minus 2. So I'm going to multiply both sides by c times c minus 2. And so when I distribute this in here, I'll get c times c minus 2 over c minus 2 plus c times c minus 2 over c, and then 2 times c minus 2 over c times c minus 2. Now you do not need to go and write it out like this. If you go through and you can take it and go from this part right down to here in the reduced form, then go ahead. But at this point I can go and reduce these. And so here the c minus 2's will drop off, here the c's drop off, and here c times c minus 2 drops off. And so what I'm left with at that time is c plus c minus 2 equals 2. Now at this point we're into a linear equation, makes our life a little bit easier. Combining the like terms, I get 2c minus 2 equals 2. So 2c equals 4, and I get c equals 2. Now this is where we go through, and you have to be careful. When you have a rational equation, anytime you go through and have to multiply both sides by something, you are producing possible extraneous solutions. And in this case, that's exactly what we've done. Because if you take this solution here, the c equals 2, if I go back to the original problem, if I was to plug that into this problem right there, if I plug it in here, I'm going to get a 0 in the bottom. And same thing over here. So therefore, even though it worked out this way, I know that c equals 2 is actually not a solution. And so this particular problem is going to have no solution. The thing to remember when working on these things: number one, make sure when you multiply through, to double check that solution to see if it is actually a possible solution to the original problem. Don't go back to anything but the original problem when checking your solutions. Again, as before, take a minute, pause the video to make sure you're comfortable with everything, and when you're ready, we can move on. The next type of equation we're going to look at are the radical equations. And these are ones that involve square roots, cube roots, and so forth. Now the ones you really have to be aware of are going to be the even roots. Square roots, fourth roots, sixth roots, those types of problems. Because with those ones right there, when we're working in the real number system, we cannot have a negative result underneath the square root. And so therefore any solution that would give us a negative under the square root would have to be eliminated. So this is another one that can produce extraneous solutions. And so what happens on this one? The first thing I'm going to have to do when I'm working on a radical equation, I need to get the radical by itself, which in this case it already is. And then the next thing I'm going to have to do is go through and get rid of the radical. In this case, to get rid of a square root, I'm going to square both sides. And so I take that square root squared equals x minus 3 squared. What you have to remember is x minus 3 times x minus 3. So you do have to FOIL that. I see a lot of mistakes happening here. You got to remember that when you see x minus 3 squared, it requires you to FOIL it out. And so when I square this, the square root, just when you square a square root, it just drops off. So I have 2x squared minus 8x plus 1 equals, when I FOIL that, it's going to be x squared minus 6x plus 9. At this point, I'm going to go through. I see that I have a quadratic, so I'm going to get everything over to one side of the equal sign. I'm either going to factor it if possible, or I'm going to use the quadratic formula. In this case, I subtract x squared, I add 6x, subtract 9. I get x squared minus 2x minus 8 equals 0. And I can check, and I go through and I say, okay, that does factor. I can go through, I get x minus 4 times x plus 2 equals 0. And then setting each factor equal to 0, I get x equals 4 and x equals negative 2. Of course, we still want to check to see what's happening. In this case, when I plug in 4, I really don't have any issue. When I plug in 4, I am going to get 32 minus 32 plus 1. So I have the square root of a positive 1 equals 4 minus 3, which is 1. So I get the square root of 1 equals 1, and that's fine. When I plug in negative 2, though, the issue is not here with the square root. It's over here. When I plug in the negative 2 in this case, I am going to get a positive. I'll get 8 plus 16, which is 24, plus 1, which is the square root of 25. But in this case, when I plug in negative 2, I get negative 5. Now, what you have to remember, that square root symbol always means the principal root, and therefore is always going to be a positive. So the fact that when I plug negative 2 in, I get the square root of a positive 25 equal to negative 5. That would not be true. That's not the case because this is supposed to be the principal root. And so in this particular problem, negative 2 is not a solution. My only solution on this one is x equals 4. Our third type of equation is what's called a quadratic form. And you have a quadratic form when you look at the original problem and you say, oh, I see 3 terms, in this case 2 times x to the 1/2 plus x to the 1/4 minus 1 equals 0. So I have 3 terms. And the other thing I want to look at is look at the exponents. If this exponent here, if the bigger exponent is 2 times the smaller one, I do have a quadratic form. So in this case, 1/2 is equal to 2 times 1/4. So that means I have a quadratic form. And what I'm then going to do is I am going to do a substitution. And again, you may remember doing this last year. If you don't, that's okay. Make sure you're comfortable with this. And also, if you are comfortable going from, you can choose not to do that substitution if you are comfortable going from here right down to this piece here. But the idea is to go through and make that substitution so it looks more like a quadratic. So I'm going to let u equal x to the 1/4 power, just the power on x that we have there. So u is x to the 1/4. So when I square it, I get x to the 1/2. So this problem right there can be written as 2u squared plus u minus 1. And then I can go and try to factor it. So it's got to be 2u and a u. And minus 1 plus 1 ends up factoring it. In which case, I can now go through, since it's factored, I can make that replacement. Remember I said u was equal to x to the 1/4. So I'm going to replace the u's with x to the 1/4. And so, in this case, I will put the x to the 1/4 in, and then set each factor equal to 0 and solve. So on this first one, I get 2x to the 1/4 minus 1 equals 0. So I solve it, I'll get x to the 1/4 equals 1/2. To solve it for x, I'm going to have to take it to the 4th power. So when I take it to the 4th power, x is 1/2 to the 4th, and 1/2 to the 4th power is 1/16. The other one, x to the 1/4 plus 1 equal to 0, and I go through and I get x to the 1/4 equals negative 1. Well, right away, that should cause you an issue because we know, number one, this 1/4, when you see that 1/4, that is a fourth root. And a fourth root is going to end up being a positive number when you work with that. So in this case, on these particular problems right here, that is going to end up being an imaginary solution. You could also find that out by going through and finishing that up. If you finish that up, you're going to get that x, when you take it to the fourth power, you're going to get x equals 1. And then if you plug everything in, go back to the original problem, put 1 in for x, you will get 2 plus 1 minus 1, so I'll end up with 2 equals 0, which is not a true statement, so I know that this right here is actually not a solution. My only solution for this particular problem is 1/16. The next problem that we're going to look at is where it's something that we can factor, but it's not a quadratic. And a lot of times this is going to be something that's going to involve a common factor that I'm going to pull out. And one of the things you have to remember here that I want you to keep in mind is that when you divide a power by a power of a by another power of a, I will subtract the exponents. So it'll be the a raised to the top exponent minus the bottom exponent. So what's going to happen in this case? I'm going to have this particular equation right here. U to the 7/3 plus u to the 4/3 minus 20u to the 1/3 equals 0. So what I'm going to do on this one is I'm going to pull out the common factor. And my common factor will always be the smallest power of u. I don't care if that smallest power is a positive or negative. You always pull out that smallest power. So I'm going to pull out u to the 1/3. Well, when I pull u to the 1/3 out from here, that's like dividing each of these by u to the 1/3. So when I do u to the 7/3 divided by u to the 1/3, that's going to be u to the 7/3 minus 1/3, which will give me u to the 6/3. When I pull it from here, I'm going to get u to the 4/3 minus 1/3, which is going to be u to the 3/3 minus 20, because that was the positive common factor I pulled out. So I get u to the 1/3. When I simplify it, I get u to the 1/3 times the quantity of u squared plus u minus 20. Now at this point, now it's something I can factor. And so I will factor that. I will get u to the 1/3 times u plus 5 times u minus 4 equals 0. And setting every factor with a u equal to 0, u to the 1/3 equals 0 when u is 0. U plus 5 equals 0 when u is negative 5. And u minus 4 equals 0 when u equals 4. So I take a look at this one on here, and yes, you might be sitting there thinking, oh wait, we can't use the negative 5, but that's not the case in this problem. Because of the fact that we are taking a cube root, cube roots, you can have a positive or negative underneath the cube root. So in this case, all three of these values would be solutions to this particular problem. I'm not concerned about cube roots. I'm not, and so I'm in decent shape. You will always want to check though, and you're right to be concerned when you see fractional exponents. You want to make sure that you're not dealing with something that you can't work with. The last type of equation we're going to look at is an absolute value equation. Now, generally what you want to do with an absolute value equation is you want to go through and get the absolute value by itself. So in this case right here, I have 3 minus the absolute value of y plus 9 equals 11 minus 3 times the absolute value of y plus 9. So I can see a common factor. So I'm going to want to combine the common factors. I'm going to subtract 3 from both sides and then add 3 times the absolute value of y plus 9 to go through and get 2 times the absolute value of y plus 9 equals 8. Or when I divide by a positive 2, I get y, the absolute value of y plus 9 equals 4. Now at this point, you have 2 different possible answers you have to keep in mind. because I know the absolute value is defined as the distance a number is from 0. Well, there are two numbers whose distance is 4 away from 9. So what I'm going to have to do is I have to go through and work with both of these. I know what's inside. I have to look at this in terms of what's inside the absolute value symbol. Because the absolute value of y plus 9 is equal to 4, I know y plus 9 is equal to could be equal to negative 4, or y plus 9 could equal positive 4. And at this point, once I have it broken up in both of those, I can solve it, and I'd get y equals negative 13 or y equals negative 5. So this is a quick look. This completes our quick look at the other types of functions that you have to deal with, the rational, radical, quadratic forms, things that could be factored, or absolute value equations. Make sure, again, that you're comfortable with the examples that we have here. Again, you can look in section 0.3 for other examples of these problems as well and try some there. But these are things that you're going to be working with throughout the year in this class, so make sure you're comfortable. And if you have any questions, be sure to ask them in class.